All right, so this video is just kind of an Algebra 1 review of factoring, and we're warming up a little bit with writing 60 in prime factored form. So what did, just out of curiosity, what was the first number you used to factor 60? 6 and 10, 12 and 30 and 2. A bunch of numbers are being thrown out, right? All right, so I'm just going to pick, for the blue, I'll go 6 and 10. And then for that green, okay, you went with 12 and 5. All right. Are they finished? Is the 6 and 10 in prime factored form? No. So we keep going. That's 3 times 2, and that's 2 times 5. Now they're all prime factors, so it would be 2 squared times 3 times 5. With the 12 and 5, the 5 is done, but the 12 is 4 times 3. 3 is prime, but 4 is not. So I assume you kept going that way, right? But you still end up with 2 squared times 3 times 5. And that just illustrates 2 of the many ways you could factor a number, 60, that you could factor 60. Now, what we're going to be doing is factoring algebraic expressions. There's not like a number of ways to do the same problem, but there are a number of different methods to be used in different situations, okay? So it's going to be tricky, but the next table kind of puts it all together for you. We will be factoring using these techniques. Factor by GCF, greatest common factor, factor by grouping, factor by what I call Floyd, and using formulas, which there are 3 formulas. You notice how these 2 at the bottom are highlighted in gray? We actually won't cover those formulas until Learning Target 5, until after the first quiz of our next unit. So we're only going to focus on the ones that aren't highlighted today, okay? And in fact, we're going to skip factor by grouping. I'll save it for a separate video, okay? So, greatest common factor. You can use it with any number of terms. Any number of terms, and you always want to check for it first. Always check for a greatest common factor first. Now, what does it mean to have a greatest common factor? All right, each of these techniques, while I'm explaining them, I'm going to connect them to something you already know with at least 2 questions. So, for example, the previous knowledge, 2 times x, 2 times 3, you clearly know that's 2x plus 6, right? You know how to multiply that, right? Okay. With part B, multiply 3a times a, and you get, do you remember this one? 3a cubed, yeah, 3a cubed. And 3a times the 3ab would be 9a squared b. And then last, the 3a times the 4 would be 12a. That's old stuff, right? But I think it helps to see the old stuff, to see the multiplication, right before you undo the multiplication. In these 2 problems, A and B below it, and the whole notes work this way. We're starting with the answers we just got, and we're factoring them. All right, so in this factoring using the GCF method, letter A, 2x plus 6, what is the GCF of a 2x and a 6? In other words, what do they have in common? They have a 2 in common. So you take that 2, and you take it out of the 2 items that were there. And when you take a 2 out of a 2x, it's kind of like this. It's kind of like thinking about what would you multiply 2 by to make the 2x? You need an x right there. What would you need in this second blank to keep it 6? It'd be 2 times what? 2 times positive 3. And again, the answer, the factored form, is what we started with in the part A above. You see that connection? All right, that theme is going to be in the notes everywhere. The answers are already there. The factored answers are already there because we're going to multiply them first so we can make those connections. Then there's always going to be 1 or 2 problems for you to try on your own using that method, okay? All right, so, but it's just difficult to think about it backwards. Try to force yourself to not look up here at what we just did. What's the GCF of a 3, a 9, and a 12? Look at the numbers first. What's the GCF of a 3, 9, and 12? A 3, all right, so the GCF of 3. Now look at the letters one at a time. Do they all share an A? So all three terms, yes, 3a cubed, 9a squared, b, and 12a, they all have an a. Do they all have two a's? Okay, so they have a GCF of 3a so far. They don't have two a's. What about b? Do they all share a b? So the GCF is 3a. Take it out. When you take a 3a out of three items, you will still have three items in that parentheses. And you're thinking about the multiplication backwards. What would be in the first spot for a 3a to multiply by this thing and make 3a cubed? A squared. And again, the answer's right up here. You can already see what's going to be there, right? So make that connection while we're learning it. What would be in the next spot? 3 for the 9. It would need to be a positive 3 times 3 to make the 9. And a times what to make the a squared b? You need an a and you need a b. And then the last spot, what would go in that final spot there? 3a times what makes 12a? Plus 4. Again, no surprise, the answer was what we started with up there. All right, now there's only one for you to try. But there is no answer anywhere. I mean, you have to go through the process of GCF on your own. So I'm going to pause the video, and you try the your turn number 1. All right, so what do they have in common? What was the number that a 10, 15, and a 5 share? Yeah, 5. Oops. They share a 5. All right, m's. There's an m cubed in the first term, m squared in the second, and an m in the third. Do they all share an m? Okay, do they share 2 m's? No, so just 1 m. And then n's, do they all have an n? They all have more than 1 n? All right, so again, they only share 1 n. If that's what they share, if that's the GCF, take it out. There will still be 3 things in here. What's in the first spot? 5 times what makes your 10? Good. 2. M times what makes your m cubed? How many more m's do you need? You need 2 more, so m squared. That's another way to think about that. And what about the n? You need 1 more n, so n. Second term, 5 times what makes the 15? Plus 3, good. Now what about your variables? You need an m to get that to be m squared, right? Do you need another n? So the middle term will just be 3m. 3m. Last term, what would you multiply 5 by to make that minus 5? Negative 1, so it will say minus. Now, will there be a 1 in front of a letter? All right, so if there's a variable that we're going to write here, we won't put a 1 there. If there's no variables, we're going to put minus 1. All right, do we need more variables? You need 2 more n's to make that n cubed, right? So it'll be minus n squared. I've got a ton more of these practice type problems. Okay, that's just the basic concept of taking the GCF out. And it's basically the distributive property backwards when you're only distributing one thing. Okay? Now we're going to skip the factor by grouping, and I'll make a separate video for it. So the next part of the notes here, in between this big vertical bar, big horizontal bar and the next horizontal bar, we're skipping all that factor by grouping. So skip it there, and skip the 2 your turns. And we get to what I affectionately call LOI. It's simply taking a FOIL problem, F-O-I-L, and working it backwards. All right, I'm going to go through the FOILs pretty fast, and I'm going to ask you to help me out. I'm going to go down the row and call you out one by one. Give me the F, give me the O, give me the I, okay? Now I'm going to get it set up. F-O-I-L. F-O-I-L. Now, it's just distribute. That's all this is. Distribute, 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 distribute. But in Algebra 1, you were probably taught with the acronym FOIL, just to remember to multiply all 4 things. So I'm going to start over here, and we're going to go down and come back up and snake our way through. All right, what's the F in the first one? X times X. Well, when you multiply X times X, you get X squared. What about the O, CJ? X times 4, 4x. Now it's a positive 4x, agree, right? So it'll be a plus there. What about the I? Positive 3x, good. And the L, 3 times 4, 12. This is a review, so that's why I'm kind of getting you going involved. In the middle two terms, they combine to make a 7. So x squared plus 7x plus 12. Notice before we move on, what are we going to do in part A below? We are going to factor x squared plus 7x plus 12. The answer we just got. We're going to factor that. Okay? All right, next one. What we got for the F? And the O? All right, and be careful on the I. Perfect, negative for A. And the L? Trey? Negative 20, very good. So they combine in the middle to make a positive A minus 20. Again, notice what we're going to factor in B. This thing we just got, right? Okay, moving on. C, F, O. That's okay, I'll draw on the line for you. That's right, negative 3y. Coming over here with the I. Good. And the L, a negative 5 and a negative 3 when multiplied makes a positive. Yep, positive 15. So the middle becomes negative 3 minus 5, negative 8. And the L is 15. Notice again, what are we going to factor in just a second? Last one. F. 2x squared, which just changes everything. The fact that F is 2x squared, it changes everything about Lloyd. Okay, anyways. O, 8x positive, good. I, 3x, and L. Perfect. Middle terms become 11x. And again, we're going to factor that in just a second. All right. There's no secret. A, B, C, and D, the factored form of the things we're about to factor are what we just multiplied. And because they're staring at us, they're easy to copy down and say that's the factored form. When they aren't there, when you don't know what was there, you have to think about it backwards. All right, so I want to illustrate the thinking about it backwards, and then you try a couple. All right, it's pretty easy with the first three, and it gets a little more difficult when the A is 2x squared, when the A is 2 and not 1. But with Loif, the way I teach it, and again, you're welcome to Google, I've said this before in class, you're welcome to Google factoring trinomials. Go to Khan Academy, go to whatever site, there's going to be a dozen other ways you can do this. Okay, and I'm going to try to find one of the nice little trick ways maybe and show it in class too, but I teach it with Loif for a reason. I'm looking ahead at the x to the fourth and x squared. I teach it with Loif because it works everywhere. But anyways, the other methods are good too. Thinking backwards, what would go in the spot here and here, the first spot to make an x squared? X and x. The two numbers that are left, the missing blanks there, those are L's. What makes a 12? When you multiply them. 1 and 12, 2 and 6, 3 and 4. Which of those sets of numbers will make a 7 in the middle when you add them? A 3 and a 4. So a positive 3 and a positive 4. Notice that's exactly what we just multiplied in part A. B. Factor this. Blank, 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 blank. In the first spot, it has to be A and A. Now it gets a little trickier, just a little bit. What multiplies make a negative 20? 1 and negative 20. 2 and negative 10. 4 and negative 5. And of course, you could flip those negatives. Negative 1 and 20. Negative 2 and 10. Negative 4 and 5. Which set makes a 1 in the middle? It's going to be a 5 and a 4. And which one do you want to be positive? Think about it that way. That's the way I think about it. I want that to say positive 1, so I want the bigger number to be positive. So that 5 needs to be positive and the 4 needs to be negative. It's a little harder when you're thinking. It's easy to look up there at the answer we just multiplied and write it down. But the thought process called Loy, just a little harder. All right, C. Blank, 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 blank. It's got to be Y and Y. Multiplies to make 15. adds to make negative 8. Only way that's going to happen is if both of your numbers are negative. Both of your numbers have to be negative for them to multiply and make a positive number, but add to make a negative. So both of them are negative, 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 and of course things that multiply to make 15 and add to make 8, 3 and 5. Now the thought process doesn't go out the window in D, but it changes a lot when you go to D. When you set up your two parentheses and you think about your F, what multiplies to make 2x squared? You're going to say 2x and x. And that just changed everything. Just changed everything. Because whatever number you put right here, drawing an arrow to it, whatever number you put right there, when you do your outer, you will double that number. If you think about FOIL, whatever number is sitting right there in that spot where I drew the arrow, when you do your 2x times that number, it's going to double that number. So really, trial and error is the best route. Trial and error. What's going to make a 4? And, well, we already know the answers. They're staring at us, so I'll put a 3 there and a 4 there. I won't put signs on them, but in my head, how I would really do this. What's 2x times 4? The outer. 8. 2x times 4, 8. The inner, 3 times x, 3. Will an 8 and a 3 make the 11 that we're looking for? Yeah, so they're both positive. All right, we'll talk about that more on number 5. You try too. Number 4 and number 5, I'll pause the video. Try them using the Loif method. Okay, so I've got my empty parentheses. I'm thinking F, x and x. And now I'm thinking L. What multiplies to make 6, but adds to make 7? 6 and 1, so that one was an easy one. Positive 6 and positive 1, perfect. Good deal. Now, in the second one, number 5 here, the F, it would be a 3x times an x to make 3x squared. And now we're looking at the L, the 5. It's either 1 and negative 5 or negative 1 and positive 5, but I also don't know, does the 5 go here, does it go there? Because it matters this time. So here's what I'm going to do. I'm going to, in black, put a 1 here and a 5 here. And in blue, I'm going to put a 5 here and a 1 here. I'm going to do a little mental math, and I'm going to erase one of those. A little mental math with the black 5 and the black 1. In my head, I don't care if they're positives or negatives. I'm just going to pretend they're positives. What does the 3x times the black 5, the outer, make? 15x. The inner would be 1 times x, 1. Can you make a 15 and a 1 turn into 2? Can you take a 15 and a 1 and make it become 2? No. Then I'm going to erase the black 5 and the black 1 because that's not where the 5 and 1 go. But I'm thinking about FOIL backwards. That's the whole process, Loif. So I'm erasing the black 5 and the black 1. Now I'm doing this in my head. 3x times the blue 1. 3x. Blue 5 times the x. 5x. Can you make a 3x and a 5x turn into 2? Yes. Now let's think about the signs. Okay? You want it to be a negative 2. So I've got the 5 in the right spot. I've got the 1 in the right spot. So this is the 5, this is the 1. Now let's think about the signs. Which one do you want to be negative? The 5x or the 3x? The 5x. So the negative needs to be on the 5, the positive needs to be on the 1. All right, that's the process of thinking about FOIL backwards. Again, there are at least a dozen other ways to do this. One of them is on page P6 of your Algebra 2 Green Book, page P6. P stands for before chapter 1. Okay? All kinds of other ways. All right, last method I'm going to show today in this video, I'll cover factor by grouping in another video, is factoring things that are perfect square minus perfect square. It's kind of like multiplying conjugates when we did the i's. In our previous concept here, a plus 5 times a minus 5, it'd be FOIL. You'd get a squared minus 5a plus 5a minus 25. And what happens to the middle term? They're gone. So we get a squared minus 25. A perfect square minus a perfect square. The second example, x times x would give us x squared, the outer negative 3x, the inner positive 3x, and the last negative 9. So x squared minus 9. So when we undo the multiplication, when we factor it, what would a squared minus 25 factor to? It factor to what we started with there, a plus 5, a minus 5. Now here's the way I apply this formula right here. I would rewrite a squared minus 25 as a squared minus 5 squared, in my mind at least, and then the a goes here and the 5 goes here. Turn it off. And then this a goes here and that 5 goes there. So it would be a plus 5 times a minus 5. In B, that would be x squared minus 3 squared. So x and x, 3 and 3, plus minus. That's pretty easy. Factoring using that formula, difference of two squares, straightforward. So you got a couple to try, and then we'll stop the video part. But we definitely need to talk about some of the practice problems, because they just add a whole other element to this factoring stuff. So try those two. You basically need to identify the formulas a squared minus b squared in each problem. So what would be the quote-unquote a in number 6? It would be b. Now that's kind of confusing because of the letter that's in it, but it'd be the b squared. And the 49 would be 7 squared. So what would it factor to? According to the formula, b plus 7 times b minus 7. b plus 7 and b minus 7. All right, what about 4n squared? That's the tricky one. What would you square? I probably should use parentheses every time. That would be a good habit of mine, to use parentheses every time. What would you square to make a 4n squared? A 2n, very good. A 2n. What would you square to make 25? A 5. So what does this, according to the formula, factor to? You got it. 2n plus 5, 2n minus 5. All right, I'm going to stop the video. I'll probably maybe make a new video at some point to show all these answers, but it's going to get extremely more layered and complicated in these next 11 or 12 problems. We're only going to do 12 of them tonight because, and if you're looking at the video, you're not ready to do number 11. You can't do 11 unless I teach factor by grouping, okay? But you're ready for all of these other 11 problems. All right, hopefully I can record a video to show those answers. But I'll stop that right